This is a cache memory question that you have a direct mapped cache. Okay, this question I have taken from the Georgia Tech University. This is a Georgia Tech University question. So let's take this. You have a direct mapped cache. You have 16 KB cache. Your size of cache memory, that is 16 KB, and you have 256 byte block size. Which of these will conflict with this address? Which of these will conflict with this address? Tell me, in the direct mapped cache, when this conflict will happen, when you have this direct mapped cache. So when you have this direct mapped cache, then when the conflict will happen, for example, let's assume this is the cache. You have 4 lines. Let's assume this is L0, L1, L2, L3. These are the 4 lines, and you have a main memory. Now you tell me, in this direct mapped cache, what happens? That any particular block that you have, any particular block, that will definitely go to this block. Okay, this particular block can only go to one line. For example, this can only go to this line. Let's assume this can only go to this line. Now the conflict will happen if there is another block. If there is another block, okay, and this is also going to this line, then the conflict is happening. Yes or no? Because in this situation, you have to replace this bi. So this type of situation is called conflict. You can, because you can notice you have a space. You can notice this memory is empty. Let's assume these lines are empty. These lines are empty, but because in the direct mapped cache, what happens? In this cache, whatever main memory block you have, that will only map to only one line. For example, this main memory block can never map to L0, can never map to L1. This will always map to L3. This will always map to L3. Even if these are empty, then you can see this is a conflict because this cache is empty. This is empty. The space is available, but still these two people are fighting. They are fighting because they have only one place to go. This is the only place where they can go. Even if this is empty, the remaining lines are empty. These bi and bj, they can never go to these lines. Okay, so this type of situation, you can see this is a conflicting situation. Now tell me the answer for this question. So an address is given to you. With this address, which address will conflict? With this address, which address is going to conflict? So let's solve this. First of all, you find out the address, I can say division of the direct mapped cache. So for this direct mapped cache, what is the address division? So the address division is very simple. For the direct mapped cache, the address division is very simple. So this is your tag. No, this is not, this is for the associative. So for the direct mapped cache, what happens? For the direct mapped cache, there is something called block offset. So this is the block offset. And you can see after this will be your index and this will be your tag. Correct? This is the tag. Now, you can see what is the block offset. Block size is 256 byte. So 256 means 2 power 8. So you can see block offset will be 8 bits. Okay. So total 8 bits are the block offset. Now, what is the index? That will depend on the line number. Okay. That will basically it will depend on the line number. It is basically same as the line number. So how many lines you have in this cache? In this cache, how many? What is the number of lines in this cache? So let's see the number of lines. In this cache, what is the number of lines? That is, the size of cache memory is 16 KB divided by the size of blocks, the line size. The line size is 256 byte. So from here, you can easily see that this will be 2 power 4 and that will be 2 power 14. It will be 2 power 14 bytes divided by 2 power 8 bytes. So that is going to be 2 power 6. Okay, that is going to be 64. So you have 64 lines. So 2 power 6 lines. So line number, or I can say this for index, you need how many bits? You need total 6 bits. Finally, for the tag, how many bits you need? You can see address size is already given to you. That is, address size is this address size. This is already given to you in the hexadecimal, and that is your, you can see 8 into 4, that is 32 bits. So finally, I can see this tag size. This will be what? 32 minus 14, right? So this will be 18. Okay. So from here you have 18 bits is the tag size, and the index size is 6 bits, and the block offset is 8 bits. Now you tell me when the conflict will happen. So you can notice what is the block number here. Can you tell me what is the block number in this? What is the block number? See, whatever scheme you have, whatever cache scheme you have, the block number will always happen like this. You have the main memory address. In this main memory address, whatever scheme you take, whatever cache type you take, set associative or this direct mapped, so this is always going to be the block number, right? This is your block offset. So this is going to be the block offset, and this is going to be the block number. So this is going to be the block number. Now you can easily see what is the block number here. The block offset is 8 bits. So this is the block number. So I can say in this, the block number is what? The block number is 1, 2, 3, 4, 5, 6. This is the block number. Okay. Now you tell me which. So definitely this block number you will fetch for this address. So when the CPU will generate this address, then from the main memory, this entire block will come in the cache memory. Yes or no? This entire block, it will come in the cache memory. So definitely I can say this will never conflict. This will never conflict because this is the same block. This is the same block. This belongs to the same block. You can notice this option 1. This is not a conflict because it will always come in the same block as this address. So these two address locations, this location and this location, they belong to the same block number. Here also you can see the same block number you have. Okay, so definitely this will never create a conflict. When the conflict will happen, the conflict will happen that when two different block numbers, when they go to the same index. Now you look at the index. Okay, now in all the options you look at the index bits. So let's see. So index bits means that is basically the 6 bits. So you can just ignore this, ignore the last 2 bits. Okay, now look at the 6 bits. So here in this index will be what? What are the index bits? Index bits will be 0, 1, 0, 1, and that will be 1, 0. So you can notice this will be the index bits in this second address. And you can see in this, what will be the index bits? What is going to be the index bits in this? So that will be 0, 1, 1, 0, and that will be 1, 0. So this will be the index bits. Okay, because you can notice index bits are 6 bits. And what is this? What in this? I cannot see this actually. Something is this. This message is coming on the screen. This air mint message. So I cannot see this. So you can check it out. Like what is this? Can you tell me what are the index bits in this one? Last one. This air mint message is coming on the screen. So I cannot see this message. Please tell me. Let me know. Okay. So that is 1, 6. Okay. So finally it will be 0, 1, 1, 0. 1, 6. So that will be 0, 0, 0, 1. Okay, so that will be 1, 0. Okay, so like this. So now you tell me. So finally you can see that these index bits. Okay, and your original, what is the index bits here? So that will be 0, 1, 1, 0, and that will be 1, 0. So let's see the index bits when they are matching. So they are matching here. They are matching here and they are matching here. Okay, so in these two addresses they are matching. So what it means? It means they are different blocks. So the answer will be this and this. Okay, it means they are different blocks. These two are different blocks and they are mapping to the same line number. Different blocks are mapping to the same line number. So that is the reason answer will be option C and D. Yes or no? See, option A will not be the answer because that will not conflict. The given address in your question and the option A address, they belong to the same block. Are you getting my point? Pratik, they belong to the same block. So when you access from the main memory, the block will come in the cache memory. So these two addresses, they will never create any problem. They will never create any conflict. Because of one address, you will never kick out the another address, right? Okay, because when you access either the address given in the question or you access the address that is given in the option A, if you access any of them, if the CPU will generate any of them, then the same block will come from the main memory to the cache memory. Okay, so these two addresses, they will never conflict. And you can see option number B, that will not conflict, because the address in the option number B, that belongs to a different block. Okay, so you can see that will go to a different line. Okay, that will go to a different line, because you can see the line number, or I can say index bits, those are different. So the address that is given in the question, you can see this address, look at this address, and look at this address, they will map to different lines. Okay, so definitely they will never conflict. But you can notice that this address and this address, they belong to the different blocks, their block number is different, and they map to the same index, or I can say they map to the same line, so they will conflict. Similarly, this address and this address, you can see they also belong to the different block number, but they will map to the same line number. Is this clear? Please tell me, let me know, is this point clear to everyone? Anyone has any doubt in this question? So for this question, the answer will be option C and option D. Okay, so this is a simple question from the direct mapped cache. I hope you understood. So remember, only conflict will happen when you have two blocks, two different blocks, where you have B1, where you have B2, and these are different. B1 and B2, these are different. Okay, and they map to the same line, and they map to the same line. This type of situation is the conflicting situation. Okay, this is the conflict. This type of situation is the conflicting situation in direct mapped cache. Okay, is this clear? When they go to the same line. So now let's move on. So this similar question you can do. So let me give you this question as a homework. This is a very similar question from the direct mapped cache. This is just a, I can say, replica of the previous question. Okay, in this question, your main memory is 8 blocks. So you can see in this question, your main memory has 8 blocks, and you can notice your cache memory has these are the addresses. These are the main memory word addresses. Okay, so these are the addresses that we need to access. Okay, and the question is asking, what this question is asking, let me tell you. It is asking that after these, give the screenshot of, this is the cache memory. Okay, this is the cache memory. Cache memory has 8 lines. This is the cache memory. This is the cache. So this cache memory has 8 lines. Okay, and you can notice the size. This is the line size that is given to you. The line size is given to you, and these are the main memory addresses. And the question is asking, after these, what will be the content of cache memory? So basically, give the content of cache memory. Content of cache after accessing these 4 addresses. Okay, once you access these 4 addresses, then what will be the content after accessing these 4 addresses? So once you access these addresses, then what will be the content of this cache memory? So this is a similar question as the previous. So let's see this question. This is an interesting question. The next one. Tell me the answer for this one. This is an interesting question from the cache memory. A very simple question, and let me tell you that this is a GRE question. This is a GRE question, computer science question. So few years ago, there was GRE computer science exam. Nowadays it is not there. Okay, this is GRE computer science exam. So I think it was till 2012 this GRE computer science exam used to happen. Nowadays it does not happen. Okay, so you tell me the answer for this question. The question is saying that you have a processor which is word addressable memory. There is a processor with word addressable memory, and you have two-way set associative cache. So basically every set in the cache you have 2 lines. Okay, in every set you have 2 lines. A cache line is 1 word. Okay, the block size is 1 word. Only 1 word block. So a cache entry contains a set of 2 words. Can you tell me what this cache entry means? Can you tell me what this word means? It is clear from the question what this word means. The question is saying that cache line is 1 word. Okay, in one cache line you have 1 word. Now the question is saying that so a cache entry contains a set of 2 words. So what is this cache entry? This cache entry is basically a set, because you can see this is a 2-way set associative memory. Okay, this is a 2-way set associative cache memory. So in this every set has 2 words, right? In this, every set has two lines. Every set has two lines. And every line, you can notice every line has one word. Every line has one word. So every set has two words. Correct? So in this situation, remember in this question, you can read the question, you can carefully understand that this cache memory, this cache entry means set. Okay. The question is saying if there are m words of main memory, it simply means m blocks. Because one word means one block. You can notice one word, one block. Block size is already one word. So block size is already given to you. That is one word. So I can say there are total m blocks. You have m blocks. Now what the question is saying? The question is saying there are C cache entries. This means C sets you have in cache. In case you have C sets, m blocks in the main memory, m blocks in main memory, and C sets in the cache. This is the data that is given to you. Now the question is asking how many words. Word means block. How many blocks of main memory map to same cache entry? Can you tell me? Tell me what is the answer? Let me know. See, did you understand the question? See, in this question, this cache entry word is given. This is something new. Yes or no? This is something new. This cache entry word is given. But in the question, it is very clear what it means. Correct? This is a question from the GRE exam. This is a standard question. Okay. And you can notice that in this question, everything is very clear. When you read the question, everything is very clear that one word means one block. One block contains only one word. So word means block. Block means word. Okay. The size of line, every line has only one word. And you can notice cache entry has two words. It simply means that cache entry is the set. So you have C set in the cache memory and you have m blocks in the main memory. So now the question is asking how many blocks will map to the same cache entry. So the answer is very simple. That will be equal to what? That will be equal. That will be equal to m divided by number of set. Yes or no? That will be equal to number of set. So the answer will be option C. Yes or no? Answer will be option C because we already know in the set associative what happens in the set associative. In the set associative, this is happens that you divide this into set. For example, let's assume you have two set. Let's assume there is set, or let's assume you have, maybe you can have four set. So let's assume you have total four set you have. So this is a set, this is a set, this is a set. So you can notice set 0, set 1, set 2, set 3. Now in these set you can have, for example, maybe you have two lines, two lines, two lines, two lines. Okay, so this is a two-way set associative. This cache memory is two-way set associative cache. Now you can see that what will happen. In the main memory, let's assume you have total 16 blocks. Let's assume you have total 16 blocks. Then what will happen? You can clearly see that there are 4 set and there are 16 blocks. So this will happen that 16 divided by 4 means 4 blocks will go to one set. Yes or no? So I can say 4 blocks, 4 main memory blocks can go to S3, can map to S3. Okay, so very simple. So that is what you have to do. Very simple, that you have m blocks in the main memory. In the main memory, you have m blocks and you have C set in the cache memory. C cache entries means you have C set in the cache memory. So the answer will be m divided by C. These many blocks will map to same cache entry. So the answer is going to be option C, not option B. Okay. Remember, cache entry size is C. So the answer will be option C. Now let's see another interesting question. Tell me this one. This is another GRE question. Let's see this one. Another GRE question. So let's see this question. Again, this is another question in the set associative. K equal to 2 means you have two-way set associative cache. And the question is saying that each location in primary memory map to any of the K locations in the cache. So you have P locations and you have C locations in cache. What it simply means, read the question and you can easily see that it is saying that there is a K-way set associative cache. You have a set. This is a set in which you have K, K lines. So let's assume there are total K lines per set. Now you can notice that whatever block you take, it has freedom for how many lines? Can you tell me? If you take any main memory block, how many lines it can go to? Simple question I am asking. You have a main memory. This is your main memory. How many lines it can go to? It can go to any of these lines. Yes or no? So it can go to k lines. It can map to any of these k lines. Correct? Very simple. Okay. So because this block will go to only one set. For example, let's assume this block is going to this set. Then it simply means that it can go to any of these k lines. Any of these. Now the question is asking on the average, how many different locations of how many different, here location means block, because here this is saying that you can see each location maps to any of k location. So here basically this location means block. So now the question is asking how many different locations of primary memory map to particular location in the cache. What is the answer? On average. So you can notice that to a particular line, how many people will go to a particular line? So to a particular line, the answer will be number of p is the number of locations, p is the memory blocks divided by how many, c by 2 divided by number of set. These many will go to per line. Yes or no? These many will go to per line, because remember this is the number of set and this is the main memory blocks. So the answer will be 2p divided by c. Is this clear? Let me know. And this is the main memory blocks. So the answer will be 2p divided by c. Is this clear? Let me know.